that's what we'll be focusing on today. So a line of best fit, or a trend line, is a straight line that best represents the data on a scatter plot. This line may pass through, two points, two of the points, one of the points, or none of the points. And that can happen with none, but you really want to aim for two, and we'll talk about that later. So again, a line of best fit, you have a scatter plot, and you're just trying to follow that trend. Remember, there's different trends or associations, and we'll talk about that in our steps. So first thing, we're going to do our steps before we do our formula. So step one, we're going to create a scatter plot, and you should know how to do this. We're going to create a scatter plot of the data on the graph paper. We're going to draw a straight line, so we're not doing any curves. It needs to be a straight diagonal line through your points that follow your points association. And I left kind of a little blank because these are the two associations you'll be looking for in the data. There's three associations. So the first one is a positive association. So again, all these are a review. In the positive association, we know dots are going up. Then there's a negative association. And we know that's when our dots are kind of traveling down. And lastly, there's no association. And hopefully we don't end up with this when we're trying to find a line of best fit, but if you do, it looks like this, where the dots have no pattern, they're just everywhere. Okay? So then step three, we're going to find 2 points. That's why I said 2 is always best, that you think will be the line of best fit, that you think will be on the line of best fit. So you want to kind of, before you draw that line, find like points that you'll be able to go through. You need at least 2. We're going to calculate the slope of the line through your 2 points. And again, we're going to use the slope formula. So use slope formula. And we'll talk about slope formula in a minute. And then you're going to write the equation of the line. So the equation of the line is always in the form of y equals mx plus b. Alright, so lots of this is review. We're just adding that layer of line of best fit. So, slope formula. Let's talk about it. The slope formula needs 2 points to find the slope. So let's say you have 2 points. You're going to have x1, y1. You're going to have x2, y2. This is not your formula. These are the 2 points you need. Okay? So those are 2 points. The formula is going to be m equals y2 minus y1 over x2 minus x1. So this is the actual formula. This is how you're going to set your points up. You'll get your points from your table or your graph. Most likely your graph, because it should be on your line of best fit. And again, you want points that are on lattice points or lattice lines. So those are just intersections. Okay? Then you have your point slope formula. For your point slope, you need 1 point and in the slope. So you need 1 point in your slope to find the slope intercept equation. So you need x1, y1, and m. So remember, these are like what you need. Okay? Need. The actual formula is going to be y minus y1 equals m parentheses x, x minus x1. So again, this is x. There's nothing here. X minus x1. Please make sure you write that correctly because it's so important. Y minus y1 equals m parentheses x minus x1. Just like how it's y minus y1, it's x minus x1. And we'll practice this later. This is going to help you find the equation of your line without having to do anything extra to find b. This will give you b automatically. So I'll write that. Equation will give you b in y intercept form. Okay? that down. Now we're going to practice. So, so the first thing we're going to do is be looking at fat from sandwiches. So fat versus fat and calorie from sandwiches. So that's our title. Fat / calories from, and this is sandwiches. Okay. So the first thing that we want to do is to plot these points. So we got to know which ones are x and y values. So this is our x, this is our y. So we have total calories here. And then we have total fat here. Okay? So we want to pick a scale that's going to fit all these numbers. And as I'm looking at my x's, the highest it goes to is 34. So I'm thinking we can count by 5s on here. Let's see. Notice I'm doing this part with my pencil. Because sometimes I make mistakes. So we know 0's here. So this will be 5, 10, 15, 20, 25, 30. Oh, heck. We can do a little bit. We can do 2's. Spread, because the thing is you want to spread it out. So let's do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Let me make sure I did this right. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. And I'll end with 50. Boom. And then looking at my calories, these two, like the highest I see it going is 590. So let's see. We can count by so I think counting by so we're actually going to have to count by 50s. Or we can do, let's see, 25. Okay, yeah, 25 will work. So, 25, 75, 50, 100. 25, 75, 50, up 25, 50, 75, 200. And you can put like, you know, in-betweeners in there. So hopefully you can see that. Just counting by 25s. So 25, 50, 75, 300. 25, 75, 25, 50. Why do I keep doing that? There we go. 75, 400, 25, 50, 75, 500, 25, 50, 75, 600. All right, so then we have it all the way up to 625. So now that we have plotted our points, or our scale, not our points, we have our points now. So I'm going over, I'm just going to pause, I'm going to do a couple, then I'm going to pause it and just let you do it. So going over 9, which is like right here in between, and 260, which is like right here. 13, so I'm just finding like 13, which would be like right next to here. Remember this is 14, so 13's in the middle. And then 320. See here, because that's 25. 21 and 420. Right here. So you get the gist. I'm going to pause it so I don't take up too much time. Okay, so I plotted all my points. And as you can see, we can already tell the trend or the association that we see. So the association is like increasing. So as total fat increases, calorie increases. And so what you want to do is just take a ruler or just a straight edge. Doesn't matter. Find something that's straight. I'm going to use a nightbuck. And I'm going to draw my line that matches this correlation of positive. It's a positive correlation or association. And I wanted to go through most of my points, but specifically 2 of them. I've already kind of identified my 2. You're going to just draw that line through. Again, you can choose whatever 2 lines you want, but for these purposes, make sure you're choosing the same lines I'm doing, because we'll get a totally different equation if you choose something different. Okay, so I chose these 2 points on my line. So notice this is a positive association because it's increasing. It's going up. You can see that this line is cutting through. And it's hitting at least 2 of my points, but it's like in the middle of my points, which is like good. It's like the trend we want. So now taking the 2 points, we need to identify those 2 points and what points they are. So this looks like 20. So my point that's over 20 and up 440. So picking 2 points, 20, 440. So again, we already did step 1. We plotted our point. Step 2, we drew our line of best fit that matches the positive association. Now we're picking 2 points that are on our line of best fit. So you can't pick lines that are not on the line of best fit. They have to be on them. And so again, this was a 20, and this looks like this was a 25. So 25 and 500. And so now we need to find the slope. So we're going to use our slope formula. So remember, this is going to be x1. This is going to be y1 because this is our first point. This is x2, this is y2 because it's our second point. You cannot mix up, you can't do x1 and y2 and x2 and y1. Like your 2's stay together, your y stay together, your 1 stay together. So my formula is m equals y2 minus y1 over x2 minus x1. Okay? And so now we have y2, which is 500, minus y1, which is 440. Over x2, which is 25, minus x1, which is 20. Okay? And so now we're just going to work these out to get our answer. So you're just doing 500 minus 440. You got 60 here. And then 25 minus 20, which is 5 here. We can simplify this even more. We know 60 divided by 5 is just 12. So that is going to be our m. So now, because we can't tell what b is, like we can approximate, but we don't want to approximate, we want to use our formula. We're going to use our point slope formula. So our point slope formula, we're just going to use our first point and our slope. So we're using m equals 12, and we're using 20 and 440. So this is x1, this is y1. And we're using our formula of y minus y1 equals m times x minus x1. And we're just going to fill these things in. So again, y is just y. y1 is 440. M is 12. X is just x. And x1 is 20. So we filled everything in. And so now we need to solve for the form y equals mx plus b. So let's do that. So we have y minus 440 equals, and again we're using the distributive property here. So we're just multiplying 12 times x, 12x. And then we're doing 12 times 20. And so 12 times 20 is 240. Okay. And now we have to get rid of this minus 440 here. So we do the opposite, which is plus 440. So now we have y equals 12x, and just doing 440 minus 220, or 240. And again, you should get 200. So, and this is going to be plus 200, because this is greater than or negative. And so, this is our line of best, this is our line of best fit for this line here, for this line we found here. So this is our equation. So this is how we find our line of best fit. So when we come over here and look at this line, the line is y equals 12x plus 200. So that is the formula for this line. And we would use this formula to make predictions elsewise. Like if they asked how many calories would you have if there was 5,000 total fat, we would use this formula to find that. Okay? So make sure you rewind or get this down to what you need to do. But now we're going to move on to example 2. So it says, find the line. Okay, so it says the graph shows the relationship between the distance in miles a delivery truck traveled and the number of hours each delivery took. Find the equation using the line of best fit. So, of course, this line of best fit has a positive association. So we know we should have a positive slope. So association just tells you if your slope should be positive or negative. And so this is a positive association, so that equals a positive slope. So we should find a positive slope. And then we're looking for 2 points that are on this line. I want to choose points that are on lattice points so I don't have to guess. Like these are directly on intersections, so I do not have to guess at those 2 points. So my 2 points are, it looks like over 600 up 10, and then it looks like it's over 700 and up, where do these go at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? And so you know you have to do now, label it x1, y1, x2, y2, and now it's time to find that slope. So we're doing m equals y2 minus y1 over x2 minus x1. This formula never changes, so please memorize it. So our y2 is 11, y1 is 10, x2 is 700, x1 is 600. So this is just going to be 1 over 1, which is equals 1. So m is 1. And we're going to use that in our first point in our point slope formula. Y minus y1 equals m times x minus x1. So that's what we're using now. So our y is just y. y1 was 10. M is 1. And our x1 was 600. So we know that anything times 1 is itself. So we know this is just y minus 10 equals x minus 600. We just have to move this minus 10 to the other side because we want it in the form of y equals mx plus b. So when we do that, we get y equals, because this cancels, x minus 590. And remember, your x always comes first in your equation. Sorry, I didn't like the way it looked. X minus 590. And so that would be our formula for the line of best fit. Some people would ask, like, do you put the 1 in front of the x? You can, but we typically don't because we know that anything times 1 is just itself. Alright, lastly, sometimes you're going to use the line of best fit just to make predictions. So the scatter plot shows, below shows the average yearly consumption of bottled water by people in the U.S. starting in 1990. So it says, using the line of best fit, predict the average consumption of bottled water in the year 2000. So to do that, we are just going to, so it's asking, using the line of best fit, predict the average consumption of bottled water in the year 2000. So we just need to first go over, because the line is already drawn, go over to 2000, and we just need to find it on this line. So we're looking here. This is our prediction based on the line. So we would say, the average consumption of bottled water in the year 2000 would be, and again, this is your point, so you're just going over. So you know this is counting by ones here, so this would be 19, and we're looking at gallons. It's important to know what everything means. It would be 19 gallons per person. So you got to make sure you write complete sentences that make sense to your to what the question is asking. So again, sometimes you can just draw the line of best fit and just use that line to help make predictions. So I did want to make sure there was an example of that. So that is it for now. So go ahead and glue this into your notebook and update your table of contents. And then, good job.